You know, bridges were real nice for a while in limiting collision domains, but they just weren't enough. So we came up with the idea of switches. Switches are like hubs. They create that star topology like a hub does, but it also separates collision domains. Now remember, everything on a hub is one big collision domain. With a switch, every port is its own collision domain, a collision domain of one. So this means that if a conversation is going on between, say, PC1 and PC5, then you can have another conversation at the same time going on between say, PC2 and PC7. So you can have multiple conversations taking place at the same time. And the reason that works is you no longer have contention. You no longer have these collisions. So when PC1 sends a packet out over, well, I should say a frame, because these are switches, sends a frame out onto that switch, the other PCs do not hear it. The only PC that hears it is the destination PC. Now, there are exceptions. For example, if the switch doesn't yet know who's where, it has to send out a kind of flood of information to find out. But for the most part, only the receiving device hears that conversation. Let's take a look at this switch setup here. I've done the same thing I did before, in that I have this device here, which is now a switch, and this device, and these were hubs in a previous diagram. And remember, I had a bridge over here in between somewhere. But now what we have is several collision domains here. In fact, I have one collision domain right here, because every port on a switch creates a collision domain. So let me see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 collision domains here now on this. Now I have one big broadcast domain, right? Everything coming off of this router is a broadcast domain. And all of these are collision domains. So that's how switches work, and I can have a conversation going on, say, from here to here, and I can have another conversation going on, say, from here to here, and another one yet going on, say, between these two, all at the same time. So that's really nice, and so switches are very, very efficient and effective. Now, switches also act as repeaters, just like hubs and bridges do. Switches also keep a table of the port number to the MAC address number of the PC. If we go back here again, these ports each have numbers, right? 1, 2, 3, 4, 5. And then each of these devices here has a MAC address, some MAC address on it. And so it says, oh yeah, port number 2 here knows that is connected to this MAC address, and port number 3 over here is connected to this MAC address, and so forth. So that each port number to MAC address is mapped out on this thing. And they keep this address, by the way, we call that a CAM table, and content addressable memory is what it stands for. So the CAM table keeps track of what devices are attached to what port on the switch.